In this video we're going to get two parts for the price of one. We're going to work on the hitch peg and the linkage peg, and you may be able to tell that they're similarly shaped. In fact they are. And so we're going to make one part. We're going to start with the hitch peg. We're going to make that using parametric methods, and then we're going to be able to just change a couple of parameters in it to make the linkage peg. So how we're going to do that is summarized here. First of all, we're going to do a revolve here. So we're going to have to basically draw the hatched area here, and the tables below here, we've seen this before, and it's how we're going to parameterize this part. We're going to define a user parameter d, which is equal to the diameter of the base of this hitch peg, 0.25 inches, and then it should be clear that if we dimension this thing in the right order, we can use parametric tools. For example, the initial base is going to be half the diameter of the radius because we're doing a revolve. It's numerically equal to 0.125, but that'll be d over 2. And d1, which is this distance here, is equal to 0.5. That's twice d, 2 times d. And as it turns out, the creator of this part made this distance here, 0.65, equal to 1.3 times d1, which is that one. That was convenient. And finally, d3, which is the spherical radius here, is just a number that we're just going to have to put in. Okay, so let's begin by making the hitch peg. And first we're going to define the user parameter and make that equal to 0.5. So let's go here and let's make a new part on the XY plane. And let's go to our parameter table. For our user parameter, I'm going to call this d. I could call it anything, but I'm going to call it d, and it's 0.25. And just for documentation purposes, in case somebody wants to do this, modify this part later, this would be called, we could call this the base diameter of the hitch peg. Done. Okay. Now, I'm going to make this in such a way that I dimension it in an order which is consistent with this table. So you're going to have to think about that as you do this part. To use this table, you have to dimension this thing in a certain order. So let's begin. First, I'm just going to make it in general shape. So this, we're going to go there to about 0.65, click, and now I'm going to use that trick that we often forget about of making arcs using the line tool. So I'm going to click and hold and move in a direction. In this case, it's the right direction, and let's see what happens. So click, hold, and it makes an arc. And if I let up on the left mouse button, it completes that arc. Come back a little bit, left click, and then continue on there, and then back home. Now I've studied this table quite a bit, so I know the order in which I need to do these. And so you'll need to study this table. So the first dimension is right here, and that is d over 2, as we can tell by this line right here. The next one is twice d. It's d1, so d times 2. The next one is this distance here, which if you review that table, you'll find that's 1.3 times d1. And finally, the last dimension is the spherical radius of this part, and that's 0.208. And we're fully constrained at this point, so we can do a revolve. And then we'll check the parameters table to make sure that everything is okay. So here's our revolve around that axis, and you can see that that looks like it made the hitch peg. Let's go to our parameters table, and d is 0.25, d0 is 1/2 d, twice d for d1, d2 is 1.3 times d1, and then d3, which is the spherical radius, is 0.208. Okay. So we're told also that we have a bottom chamfer to the edge of 0.01 inches at 45 degrees, so let's do that. Here's the chamfer. We'll choose the top one, and 0.01, and we'll click down here, apply, and we've got our hitch peg. I get tired of looking at the default color, so I'm just going to turn this into a nice, say, yellow. And if I come back here, so we've just made this part over here Now we need to make this linkage peg, and it's just a smaller version of the hitch peg. So we're going to use this table, and we don't really have to do any sketching at all in the graphics window. We can do it all in the parameters table. But first I need to make sure that I get my own file for the linkage peg. File, save as, save copy as, and I'm going to save that exact same file. Let's call it linkage peg. Again, I've already made this before, so it's going to ask me if I want to repeat it. I do. Now I've got two identical files, but with different parts in them. So and this is the hitch peg, so the file that I just created needs to be opened. That's kind of a quirk in when you use that technique, but I've got my own two files, and I'm not going to hopefully write over the old one. Okay, so now I've got this thing, which is still physically, at least in the graphics window, the hitch peg, but it's named the linkage peg, so I need to change this to match the linkage peg. What other? So the user parameter changes down to 0.0625. 0.0625. And there we go. D0 is still the same, it's D over 2. D1 is D times 4. So it's 4 times instead of 2 times. So let me go to D1. So this is going to be D times 4. D2 is still D1 times 1.3. And finally, I just need to change the radius, spherical radius of the top from 0.208 to 0.1562. 0.1562. Whoops. Definitely don't want to do that. 0.0625. It's this one right here, or is it 0.1562? Yeah, right there. Okay, so I'm going to click done. Nothing happens, so I'm going to hit the local update up here, and there's my part. It is already the linkage peg. The name is already taken care of. I just need to make sure I save it. Thanks for watching.